Hello and welcome to the MOOC course third module of Quantum Machine Learning. We stand at the two crosswords of technology, quantum computing and machine learning. Both have a very good revolutionary word and how we approach the problems in science and technology and industry. Together they form quantum machine learning, a field is very good for computation and intelligence. This course will guide you through the foundational concept of tools and application of quantum machine learning. Whether you are a AI interested person and very much interested in quantum field, this course will be very useful to learn about all the basic concept of quantum machine learning. In this session, we are going to discuss about what is quantum computing and next is quantum computing application and what is about the machine learning, what are the fundamental concept of quantum machine learning. First, what is quantum computing? Quantum computing is an advanced computing paradigm that powers the principles of quantum mechanics such as superposition, entanglement, and quantum interfaces to perform calculation. These principles are very much important for quantum computing. Unlike classical computers, we can easily perform informations in binary bits, zeros and ones in classical computers. But in quantum computers, we are always going to treat as quantum bits. It's called as qubits that can exist simultaneously in multiple states, 0, 1 or both. This compatibility is very important in quantum computing and this capability enables quantum computers to solve certain types of problems such very fast. So this is the biggest difference between classical computers and quantum computers. Quantum computing is an area of computer science that uses principles of quantum theory and it is having very much atomic levels. It uses subatomic particles such as electrons and photons. Classical computers, which include smartphones and laptops, you know that all the processing in classical computers are bits only. It can be either 0 or 1. In quantum computer, we know that it is a unit of memory. We can also treat that as a qubits. Quantum bits or qubits are very important to exist in more state. They have multiple states to handle all kind of problems. Linked qubits can have more properties like superposition, entanglement, and interface between each wave-like states to perform calculations as very fast. Key four principles of quantum mechanics. The first one is that, as I already told, that superposition. So superposition is a good state in which quantum particle or system can represent, but it is having a combination of multiple possibilities. Next is entanglement. It is a process of multiple quantum particles become correlated more stronger than a regular probability. So it is having more possibility to go with correlation. Next is decoherence. In the decoherent state, quantum particle and systems can decay and it is having multiple changes to be happen in the compared to the classical physics. Next, interface. In the case of interface, quantum states can interact and it can also produce more probabilities. So in the case of superposition, we can have, it is also called as quantum superposition, either zeros or ones, you know that. In quantum entanglement, quantum particles interact with each other. We can easily have a strong correlation. An interface, we can have a different kind of probability states are there. This is very useful for quantum algorithm. And the next thing is quantum tunneling. It is very useful to tunnel through the barriers when according to the classical physics. So here we can have the relationship between quantum computer hardware like quantum dots. Next is quantum computer hardware. When you are going for quantum computing hardware, we can have physical qubit, processor, controller circuits, interface, detectors, chips for trapping icons, vacuum, laser, microwave or optical systems, wiring, refrigerators, and we can have a housing and signal shielding is there. When we are going for software, error correction, control processing, languages are there, specification, simulation, debugging, programming language, compilers, schedulers, optimization, resource estimation, verification and validation, functional libraries are there. With that idea, we entered into what are the different kind of application and benefits of quantum computing. So quantum computing vision and challenges are totally different. So the first we will see about how it will be very useful for business application. So in case of business application, telecommunication, electrical power, banking sector, in the case of banking sector, we can have a risk estimation, commerce, and we can go for the market portfolio improvement. Everything is there. Designing of robotics also there. And a different kind of business application, medical services. In the case of medical services, treatments and rapid radiation treatments, accurate diagnosis, and we can go with different kind of automotive industry also. And what are the different kind of advancement is there is it is very useful in computer vision and pharmaceutical company, and we can go for the speed computation, life science and climate prediction. And in case of quantum algorithm and neural networks are very important in security domain also. Next is fundamental operation. In case of fundamental operation, we can go for confidential data processing, encrypted data transformation, connectivity, detection of attacks, and surveillance, telecommunication, network quantum technology, and safe credential processes also to be applied. Next, how it will be supported for gadget assistance. So predictive analytics for anticipating trends, find a solution and for complex problem, and quantum skills to diagnose and disease. So these are the different kind of application we can go. The next is about how the quantum computing is very useful for scalable application. We are going to build a very scalable application for all kind of different real-time application. The first one is research and optimization. So the first one is search and optimization. Here we have a different kind of algorithm is there. The Groover's algorithm is very important for search and optimization. Based on this Groover's algorithm for database search offers quadratic speed for database search. A database of 4 entries takes one lookup on a quantum computer versus 4 lookups classically. For example, if we are going to search a record, it will take 4 lookups. In classical computers, if we are going for quantum computers, we can go only one lookup for 4 entries. This could enable ultra-fast search of real-time application in financial domain and healthcare and compared to the classical dataset. This Groover's algorithm is one of the most predominant examples of a quantum algorithm designed to solve unstructured search problems. So unstructured search problems efficiently we can solve with the help of this Groover's algorithm. It is very important and which include the principles of quantum superposition, interface and entanglement to search an n element of database in case of order of root n time. So searching time is very fast in Groover's algorithm. And next we can have a different kind of real-time application in chemical simulation. In quantum computers we can go with 50 to 100 qubits could simulate complex enzymes mechanism and chemical process are to be easily used in fertilizer production, polymers and biomass production. So these are the two important application domain, and this algorithm is very useful for unstructured data. And what are the different kind of advantages of quantum computing? We can easily go for speed up in problem solving. We can go for a complex optimization problem, and quantum system is there. We can easily simulate and enhanced quantum machine learning and secure cryptography, and high parallelism is also there, and solving differential equation and novel scientific discoveries, advantages in AI and big data, and energy efficiency. And the next we are going to see about what is machine learning, because we are going to integrate machine learning and quantum computing. Machine learning in quantum computing is very very important. We can easily integrate with quantum computing to solve all kind of problems efficiently, to address the classical computers issues. The combination of this domain is also called as QML. Quantum machine learning is one of the most promising application in quantum computing. So why we are going for machine learning? You know that machine learning is very very important to solve all kind of real-time problems. We are having a exponential growth of data is there in our data set. So data behavior also to be increased with the help of a complexity. So we need to improve the performance of the machine learning algorithms. So with that quantum computing, we can easily align with the quantum machine learning with the help of superposition, entanglement, and exponential optimization is to be introduced with compared to the traditional machine learning algorithm. This machine learning algorithm is a fundamental concept of artificial intelligence. You know that it involves automatically we can learn the data with the help of decision making, and the minimal human involvement is there. So this focal point of research is both academician and industry domain. It is to be very very important for image recognition, public safety, and intelligent transportation and natural language process. So this machine learning is a subset of artificial intelligence and aims to create a model with the help of mm, data sets. So with this technical area, we can easily focus large language model and natural language processing, medical diagnostic, computer vision. So we have many real-time applications are there. Many machine learning algorithms are very important to align with linear algebra to execute matrix operations, since data are described in matrix. Performing these kind of operation on traditional computers is very very uh, difficult to handle all kind of computing resources and time. Quantum computing is very very important field to can handle all kind of computer science and mathematics and physics. This field of investigates way to for special properties of quantum physics to build quantum computers. So we can take all kind of bits as a qubits of zeros and ones. So machine learning is very very important to build a high resource intensive application based on large data sets and advanced algorithm. So why we are moving for a high resource intensive application in ML? We can go for large language data, that is large scale data. Example, we can exceed our storage from terabyte to betabytes, and distributed processing models are there. Complex model like GPT-4 and image diffusion model. Real-time processing is also there for a demand immediate response, and autonomous vehicle control fraud detection is also there. High precision. So this high precision medical diagnosis is also there for perfect accuracy, and iterative process is also there for reinforcement learning. Examples of high resource intensive application, we can go for autonomous vehicles, climate modeling environment, right, and drug discovery, finance and stock market analysis, language processing, smart cities, and astrophysics and space information system. So traditional computers are very very challenge for us to go for all kind of real-time application according to Moore's law. So here we are increasing clock speed, performance bottleneck due to the growth of data. So in order to handle all kind of high dimensional data, definitely we have to move for quantum computing to break all kind of barriers. So with that idea, we are entered into QML. Thank you, learners.